Welcome to my talk. Today we're going to talk about Kotlin and idiomatic Kotlin. I'm going to show you some practical recipes how to write idiomatic Kotlin code. And I hope this session is going to be interactive and I will have some questions for you. First question, what is code? No stupid answers. What is code?
It's the language of the computer.
Language of the computer. Okay, what else?
Instructions, how to
okay, set of instructions.
Set of instructions.
A pain.
A pain, okay. Yeah, the formal definition would be a set of instructions for a computer program. But yeah, today we're gonna treat the code as we should treat it, which is a tool. This is a tool to build an app, to integrate systems, process data, and this data processing is important because we're in the information technology field. Tool to create other tools or even to launch rockets. Back in the 90s, NASA had a space mission to Mars, but the Mars Climate Orbiter didn't reach the Mars fully. It burned in the atmosphere. And do you know what went wrong? Okay, we have something on the slides already. There were some miscalculations because the NASA team used proper units, kilograms, newtons, and team of contractors that was hired by NASA used some weird units, imperial pounds. So the rocket with the Mars Climate Orbiter started, it went to Mars, but the error grew bigger and bigger, and eventually the Mars Climate Orbiter crashed because, well, 1 pound doesn't exactly equal 1 kilogram. So we have some ways to prevent that kind of errors. So how can we be sure that our code will work? And this is a question for you again. Project is built, yeah. What else? Unit tests. I like unit tests. What else? Standardization, yeah. Conventions, run the application and get the feedback from users. Continuous integration, very well. What else? Yes, so striving for simplicity in the code. Docs. Oh, I love writing documentation. Yeah, but basically in our toolkits we have compiler, we have automated tests, we have human verification, code review, and once we launch our rocket, our application, we can get user feedback, especially in front-end facing applications like mobile. And of course, we have some logs from production, and the NASA had only logs. So, yeah, another question: how to detect those errors early on, as early as possible? In which phase?
Before we write this code down.
Before to write this code, so in the planning phase.
Yeah.
For example, introduce standardization. Okay, we are using normal units, metric. So, yeah, it's best to detect those errors as early as possible during planning phase, during compilation. But we will take another example, not rocket science. We will talk about weightlifting. And this is another question for you. How much the bar itself weighs? 20 kilograms. And someone from US and A will say that bar weighs how much? 45 pounds, I guess. But it doesn't end in the 20 kilos. Women competition bar. Do you know how much women competition bar weighs? 15, yeah. And it's not because it shouldn't be that that much, but because the bar is thicker. So, fun fact. Okay, so we have 20 kilos or 45 pounds. If we write this in the code as integers, okay, well, we have 20 kilos and we can somehow add this to other integer, 45 pounds. So what can we do to avoid that kind of errors? Well, it's not stupid. It works because it's an information for other developers. So we can add unit name to variable name. And this is pretty useful, but we can still add pounds to kilograms. So, yeah, skompiluje się. In Kotlin, we have a concept of type alias. Do you know what type alias is?
Yep.
Okay. So, how would you define type alias?
You can simplify some big generics, for example, like list something with one simple alias.
Yeah. So this won't introduce a new type. It will be an information again for developer, but not for the compiler. Type alias for the compiler will be quite transparent. So we still can add kilograms to the pounds. This is integer, this is integer. And what's the result of this addition? Integer, right. So we can come up with some kind of solution. Create a wrapper class to have compile time type safety. So class for kilograms with value, class for pounds with integer value, underlying value, and now we cannot add kilograms to pounds in a simple way. But there is some issue with doing stuff like that.
Adding kilograms to kilograms would also be a problem.
Yeah.
You need to manually recreate kilograms because you're not overriding.
Yeah, you will still need to access kilograms.value. But the issue I'm talking about is we are effectively using integers, but we are wrapping those in classes. So there is a necessary memory allocation. This is Java equivalent for this code. And yeah, each time we are creating new instance of kilograms class. But we can introduce another Kotlin idiom, value class. Previously it was called inline class. And with this value keyword, and for some reason JVM inline annotation, we can create such class that will have the compile type safety. So we will use this class as kilograms, not the type alias kilograms, but the class kilograms. And under the hood, we will have the benefits of primitive types once we introduce that kind of value class. So I think that's nice. Another thing, I don't like this notation, invoking constructor. We are creating domain-specific language at that point, so we can use another Kotlin idiom to make something nice. What kind of syntax sugar we can use here?
Extension.
Yeah, extension property. And I think you already know that if you are working with Jetpack Compose, you write 20.dp or something like that. So right now it is a very common practice. And yeah, by creating that kind of extension property, we can now write 20.kilograms and it will create value class of kilograms. So yeah, someone already mentioned it, that we need to access kilograms.value plus kilograms.value. So how can we make this notation work? We can introduce operator function for kilograms. So in Kotlin, we can use this operator function for plus, minus, common arithmetic operators to create DSL, for example, for addition. And now with this. Plus, we can use this plus sign to execute this function, adding these kilograms plus kilograms value. So yeah, let's sum this up. We introduced type alias, but it's not enough. Then we introduce value class because we wanted to have type-safe primitives without. We wanted to have type-safe primitives while using objects with primitives performance. And yeah, we started to build domain-specific language, DSL, with extension functions and operator. So other examples, not weightlifting. Okay. Let's suppose we have that kind of class. This could be effectively even value class. We have some input function that accepts email and password, and we don't want to mix email and the password. But once again, we have to access that underlying value by email.value.contains. So how can we drop this dot value? How can we use directly email contains at?
Extension on string.
Extension on string, okay, that may be the solution. But we can, string is implementing some interface. Which interface? Char sequence. So another Kotlin trick is class delegation. We can say that this email is a char sequence implemented by underlying string value. So now effectively, we can use email.contains, email plus something, and every other operation that is possible on that char sequence. So another syntax sugar, I think. Okay, let's talk about data structures. You probably know something like that. We have list with pagination, some JSON, John Doe, stuff like that, and we have some pointer to the next page of resource in our API. And how does it look like in our code? We create data class for paginated resource. We have list of data. This could be even generic data. And yeah, then data ID, name, something like that. But effectively, this paginated resource, we can treat it as a list. So again, class delegation for the rescue. We can say that this paginated resource is of type of list of data implemented by this underlying value data. And now we can say paginated resource for each map, stuff like that, and still access this next page. So that was another example for class delegation. API responses. Now we will talk something about generics. So you know that kind of code. We have response, success, error, loading. We can treat it as API response or some state of our screen for compose, data binding, whatever. But yeah, we want to be generic. So we introduce generic types to this response. And this is now a question for you. Look at this code. We have sealed class response out t, success, error. What should be in here? Because we have success of some type, but the error shouldn't necessarily be of type list of data. Error should be always the same or very similar. So what type can we put in here? What should it be? Nothing. So Yeah. When we put nothing in here, we can now introduce very nice when expression to match response for success, response for error without additional casting. So I guess nothing is something. The contract of nothing is that this is subtype of everything. And you are already probably using nothing not only in generics, but in to-do function. So function has type of nothing if it never returns anything. So, for example, it always throws exception. Unit is a type in Kotlin, so function without declared return type will return unit. But to have function returning nothing, we have to always throw exception. So let's sum this part up. We introduce class delegation to reduce some boilerplate. We used again class delegation for modeling data structures with this paginated resource. We talked about sealed classes, and we talked about nothing. So now let's write some unit tests. I bet you love this framework, because this framework was created for Java, and it has a lot of Java-specific stuff. So we have some function, test function given when then, and we want to create mock of our service. Mock, stub, whatever, some kind of test double. So we have a few things here. For starters, we are using item service of class.java. And next thing, in Mockito there is function when, and when we are using Mockito in Kotlin and we want to invoke when function from Mockito, we need to put this in backticks because when is keyword in Kotlin. So what can we do with it? We can introduce another library that sits on top of regular Mockito, and this is called Mockito Kotlin. So for starters, with Mockito Kotlin, we are defining mock inline. This is reified function. So the implementation of all of this is just returning stuff to the regular Mockito. But in here we have few interesting things. This is inline function. We have reification with generic types. So Mockito Kotlin already knows that we want to mock item service or whatever because it took it from there, and we don't have to write item service class Java. Okay, and next thing. Instead of writing Mockito, when, do something, then something else, we can use, again, domain-specific language, which comes in Mockito Kotlin and also in MockPay, great library. So our stub definition now becomes this lambda with mock and another lambdas with on some function call. What should you do? Do return that kind of entity. And again, it's very simple. We are delegating that stuff to regular Mockito when. Okay, so idiomatic Kotlin in tests. We have nice one-liners like Mockito, mock for we have reification, and once again, we are using domain-specific language with lambdas and other cool stuff. Next, assertions. Which one, in your opinion, is more readable? Assert equals or actual should be expected? This domain specific. So, in my opinion, should be is much more readable, but I am biased, so. But yeah, another interesting thing, the order of expected and actual in assert equals is different in JUnit 4 and JUnit 5. And in some other libraries, the order is not so obvious. But once we are using actual value should be expected value, output of this function should be 2, should be 3, something like that. It reads like sentence, so the order of this assertion is more obvious. Another cool stuff. Do you know what happens if we have many assertion errors in a test function? What happens when first assertion fails? Other assertions won't be executed unless we use some kind of assertion collectors, such as assert softly from cotest, another very cool DSL, and then all of those assertion errors will be collected to a single test report. So what we talked about in terms of testing. You should totally try cotest. It was previously called Kotlin test. There are many matchers with this infix notation, should be, should not have, list should have size of something, so there is many cool functions. And again, idiomatic Kotlin in here, infix, DSL. And this DSL builder for multi-assertions is very nice. I'm using it in many tests. Okay, what we talked so far about? We talked about value classes, type aliases, extensions, operators. We talked about class delegation, sealed classes, and type-safe generics. We talked about one-liners, syntax sugar, idiomatic Kotlin for testing. But that was all syntax sugar. Readability comes first. So this is example, this is actual code from the Chris Bain's TV application. This is application that is presenting supposedly cool stuff about Android development. Basically, he is integrating all the new libraries to this application just to showcase how can we use it. But this is base use case or base interactor. So in your opinion, is this readable? Looking at this function, operator fun invoke, can you tell me what it is doing? Okay, so first, it accepts some generic params, and it has option to configure timeout. And it is returning Kotlin flow with some invoke status. What is invoke status? Doesn't matter right now. Okay, and then with timeout, emit invoke started, do work, okay. We have function do work that we have to implement somehow, and yeah, then invoke success or invoke error, and another catch in here. And also we have this weird function execute sync synchronously. Okay, so, and this is usage example. This is use case, interactor, whatever, that has very simple task to do. It has to invoke, it has to update configuration, refresh configuration in some manager. So we don't need any additional params, so we are passing unit in here. Okay, and then we have to implement do work and using some dispatchers, and then finally invoking this refresh configuration. But yeah, okay, you have your answer in here, but question for you, is that code clean?
No, because the statuses could change, for example, like here.
Which status could change?
Emit, for example, invoke started, invoke success. What will happen if we decide to change them, for example?
Okay, what will happen on cancellation? Okay, we have only timeout cancellation exception, but regular cancellation won't be supported in here. Okay.
Do we actually need timeout for everything?
We don't need timeout for everything. What else?
I'm not sure if we even need flow for this.
Yeah, because most of the operations we are doing are single shot. Yeah.
Basically, you return a result as a result of the suspend function, and to immediately with updates, you can basically provide the block to the function to deliver those updates for example, for UI to consume them, update all these current details, but at the end of the call, you always receive the result.
So that kind of stuff, emitting, we started doing something should be handled on the presentation layer, not on the use case. Not in the domain, it should be domain. So, okay, don't repeat yourself. Let's agree we are not repeating ourselves with this timeouts and cancellations because we put it in the abstract class. Single responsibility, does it adhere to single responsibility principle?
No.
Okay, I checked that it is, but
Yeah, we have only one do work. So.
we are only doing work. One input of params, one output of this invoke status. Okay, but we may have two responsibilities: to do work asynchronously or to execute this work synchronously. So, not sure. But for sure, we are not complying to "you ain't gonna need it" rule. Because there is a lot of stuff we don't need most of the time, and we are not keeping it simple. Okay, other rules, closed for modification and open for extension. Do you agree? Hard to tell. Well, this is like taking sledgehammer to crush a nut. Fun fact, this image was generated by AI. Okay, so another thing, I don't like using operator fun for invoke in use cases. Execute, sync. Okay, we should do something synchronously, but this is suspend function, so synchronously or suspend? Well, Chris decide on one thing. But actually, I think this abstraction is pretty good, but it's not applicable to our project. What if we have simpler alternative? We don't have to call it use case, it can be in the domain layer, config updater with single function update. Okay, we are using dispatchers in here, the TMDB manager refresh configuration. So no flow because we don't need it, no execute sync, no artificial unit param because we defined our abstract class as generic, so now we have to use generic types. Interface is clearly stating what it should do, config updater with implementation TMDB config updater. So no EMPL suffix. And I believe that wrong abstraction is worse and will cost you more than no abstractions at all. Okay, so now let's talk about generic framework for refactoring, how to go from this to that. So the first step would be to put everything out of this box, and this could be moving all our modules to a single module, to a single package, and then we can start working on that. And once we identify those tools, we can start organizing. we can start organizing again on the floor, and once we have our tools in place, we can then put it in the new box. And it's the same process in the software while refactoring to clean code. First, we are identifying those areas that need improvements, so we have our box with tools. In this part, we will try to introduce some unit tests. Some unit tests, but without modifying content of our box with tools. And what happens next? Next, once we identified this box, once we created characterization tests, so describing exactly what is happening in our code, then we can refactor with baby steps and write proper unit tests to organize our code into new box. And the fifth point, repeat. So the clean code should serve us for readability, not for bragging, oh, I follow Uncle Bob advice. Those are guidelines, not actual rules. So I think the most overused rule is don't repeat yourself. And that's how we are ending with huge abstract classes, base view models, base interactors. So do what is reasonable. And clean code doesn't mean that we have to have multi-layered architecture. Clean architecture doesn't mean we have to have multiple Gradle modules. It is useful, but it doesn't have to be that way. We don't have to add interface for every implementation, and we don't have to adhere to every solid, dry, or other cool principle. So clean code is not about it. It's about readability, that to enhance our user experience, developer experience. So clean code is about communication, not the syntax sugar. And what about comments? Do you think we should write comments?
Yes.
Yeah, okay. Because what would happen if engineers in the NISA team or in the contractors team wrote some comment that, hey, this number is actually kilogram? Maybe there wouldn't be that rocket crash. So I'm not sure if single comment would save them, but introducing at least few rules from the software craftsmanship would be beneficial. But now we will never know. We will never know. Okay, we are coming to an end. You might ask me, where are good examples of idiomatic Kotlin? Well, in tools created by JetBrains, like this Kotest testing library. If you want to take a look at how we should write idiomatic Kotlin, go to the source, to standard libraries, to libraries created by JetBrains. They are actually good in writing Kotlin code for some reason. And another question, should we strive for writing idiomatic Kotlin? Should we write Kotlin code Kotlin style or Java style? Well, a few years ago, I would say that, oh, you should write Kotlin code in Kotlin style, obviously. But now I think that it is best to come up with a solution that will be best for you and for your team. First for your team and then for you, in that particular order. So all of this stuff I presented to you, value classes, class delegation, well, it's syntax sugar, and it's good to know those concepts. But it doesn't mean that we have to use them, because it's very easy to overuse that syntax sugar and end up with unreadable code. So my message to you is, if you are writing idiomatic Kotlin, write idiomatic. not idiotic. Thank you very much. And yeah, this is my stuff. androidpro.io. Nowoczesny Junior. This is community for juniors after the bootcamp. And Michalik Tech is my personal website. There will be some other stuff on social media.
Yeah, I can also recommend your LinkedIn. You share some quite cool stuff.
Yeah. Sometimes I even share memes. Yeah, so let's talk about Kotlin. If you have any questions right now or later, I am open to discussion.
Okay, so I think that's
So I have one question.
Sure.
How does one become a GDE, Google Developer Expert? Because it sounds awesome.
Yeah. You have to be recommended by someone from Google or other GDE. So basically, you need to promote Google stuff in some way on conferences by writing articles, stuff like that. And so you need to be picked.
you need to get in touch with Jarek.
Yeah. There's also the program Road to GDE, where there is some mentoring about public speaking, technical writing, so you might be interested in that.
Cool. So thanks once again.
Thank you very much.